Hey everyone,
Hey everyone,
welcome to
welcome to
day three
day three
of the DD
of
Nairobi's
the
Pre
DD
IO
Nairobi's
series.
pre-IO series.
Today we're diving into the
Today we're
cutting
diving
edge
into the
world
cutting
of
edge
cloud
world of
security
cloud
with a focus
security with
on
a focus
artificial
on
intelligence.
artificial intelligence.
Whether you're a
Whether
seasoned
you're a
cloud
seasoned cloud
technologist trying
technologist
to explore the
trying to explore the
possibilities,
possibilities,
this session is packed
this
with
session is packed with
valuable insight.
valuable insight.
Let's give a warm
Let's give
welcome
a
to our
warm
first
welcome to
speaker,
our first
Gauri
speaker,
Yadav.
Gauri Yadav.
Gauri is a
Gauri is a
DevSecOps engineer who's
DevSecOps
a
engineer
passion
with
for
a passion
unlocking the
to
security
unlock the
potential
security
of cloud
potential
and
of cloud
DevOps.
and DevOps.
Beyond her
Beyond
technical
her
expertise,
technical expertise,
Gauri is a prolific
Gauri is a
tech content
prolific tech
creator and
content
speaker.
creator and speaker.
She's here today to give
She's
us
here
her
today to give
knowledge
us
in
her
harnessing
knowledge in
AI for
harnessing
the next
AI
gen
for the next
security,
gen security,
an advanced
an
guide for
advanced
Google
guide
Cloud
for Google Cloud
professionals.
professionals.
The floor is yours,
The
Gauri.
floor is yours, Gauri. Okay. Hello everyone, I'm Gauri Yadav and I'm working as a cloud intern right now. And that's it, not taking much time to explain myself. Today's topic is really, really great, and let's dive into it. So, today's topic is leveraging AI and ML in Google Cloud for enhancing security, right? So, let's look at the table of contents, what all topics we are going to cover in this session. So, we would be understanding AI driven threat detection, then how AI actually detects threats and how AI stops the attack, and then automated incident response, and then introducing AI powered SOAR, that is operations for our response, and then we have with benefits of automated IR, then we will have case study, and then we would be looking at security posture management with AI. So our first section is AI driven threat detection. How even AI detects threats, right? So today we'll delve into the fascinating world of AI in cybersecurity, focusing on how AI detects threats, combats phishing, and enhances incident response with AI-powered SOAR. So I'm excited to show these insights. So how actually AI detects threats? AI uses machine learning algorithm to analyze vast amount of data from various sources such as network traffic, user behavior, system logs, many more things like that. Basically, a company who collects data can perform these kind of steps. Now let's understand it with the help of an example. Imagine a network of monitoring system that uses AI to scan million of network policies, right? Million of network policies. So how do you even work with that? How difficult is it to segregate this much amount of data? So here comes the AI detection. It has inbuilt algorithms that can help you. Wait a second, I think my Wi-Fi is breaking. Wait a second. Wait a second, guys. Wait a second. Yeah. Okay. Sorry guys, sorry for the interruption. So we were on what, imagining that we have a network monitoring system that uses AI to scan million of network packets every second, looking for patterns that divide the data into norms and forms. This can include unusual logic terms. So how we are going to deal with that? That is called abnormal data transfer or access attempts for unusual locations. So process, what is the process for this? The AI system is trained on historical data to recognize normal behavior patterns. When it encounters something unusual, it flags it as a potential threat. So, according to a study, there was a large financial institution, and in that AI detection used to detect unusual patterns of transaction late at night, or leading to the discovery of an insider threat attempting some different kind of fund transfer that was unauthorized. what other kind of technique does it use? It uses machine learning technique. What is machine learning technique have? It has supervised learning and unsupervised learning. What is supervised learning here? AI models are trained on labeled data such as known threads and beginning activities, the kind of things, the kind of data that we have already available. And what is unsupervised learning? AI identifies patterns and anomalies with prior knowledge, useful for detecting new unknown threats. And third one is reinforcement learning, that is AI system learn from their environment by receiving feedback on their actions, improving their detection capabilities over time. So what is real time threat detection in here? It is AI provides the real time threat detection by continuously monitoring and analyzing data streams. For example, an AI driven firewall can instantly recognize and block malicious traffic before it reaches to critical system. Impact. What kind of impact does it create? It reduces the time between the threat detection and response, minimizing the potential uh, threats, right? So we have so much of things, like we are implementing AI. So was there any kind of problem that we were facing earlier that we needed to implement AI into security? So the challenges that we were facing in traditional security was that traditional security methods such as signature based detection rely on predefined patterns to identify threats. Now, what other kind of limitations did it have? These methods struggle to detect new unknown threats and require constant updates. It is how much of hustle, it is how much of paperwork to update your policies every time. Now, for example, let's consider a traditional antivirus program may miss a 0-day exploit because it does not have a signature for it. So now what kind of scenario is it creating? It is creating a false positives. For example, traditional systems often produce a high number of false positives, leading to the alert figure among the security terms. Now, what other than that we were facing? We were facing scalability issues. What are scalability issues? Then traditional security system may not scale effectively to handle the massive volume of data into modern network. For example, a large enterprise with thousands of endpoints generates enormous amount of data, making it difficult for traditional systems to keep up. For example, incentive. What is that? Intensive. Sorry. These systems often require significant human resources to manage and maintain. How many number of engineers or how many number of people we need to hire just to segregate our data? Now we have adaptability. Cyber threats are constantly evolving with attackers. That means if you are implementing 10 kind of different policies for security, there are 20 cyber ethical hackers who are growing. So, and they have different kind of cyber threats. So cyber threats are constantly evolving and attackers developing new techniques to bypass traditional defenses. Example, we have polymorphic warfare. What is that? It changes the code to avoid detection by signature based system. Traditional methods also struggle to adapt quickly to these changes, leaving organizations very vulnerable. Now now we saw that what all the challenges traditional security had, right? Now, what if AI actually stops an attack and it is a phishing attack? But before we delve into that how AI stops it, let's see what is a phishing attack. So phishing attack use a social media engine tactics to deceive users into providing sensitive information and processes. The attacker sends a fraudulent email to that appears to come from a legitimate source. For example, you have your bank account and that bank account looks like that bank account look like कि for example you have made this much amount of transaction or this much amount of money has been added to your account. Now if you click on link, you would be redirected to a website that would collect all of your phone's data. And if all of your phone's data is gone, then you have your credentials, then you have bank credentials, you have your passwords and everything in there. So the attacker sends the fraudulent email that appears to come from a legitimate source. Now the email contains a malicious link or attachment. The victim clicks the link or opens the attachment unknowingly, providing credentials. Yeah, sorry, I was not sharing my full screen. Yeah, so the victim clicks the link or opens the attachment unknowingly, providing credentials that might install a malware into your system. Now, how is it even possible? For example, an attacker is posing as an IT administrator, might send an email asking users to reset their password, redirecting them to a fake login page. Now, how it would impact? Successful phishing attacks can lead to data breaches, financial loss, and reputation damage. Now, let's look into how actually AI can stop. So no, but let me first tell you about a very recent actual real world phishing attack that happened. In a recent phishing campaign, attackers targeted employees of a major corporation company, and in which they spreaded emails, and emails were intended to be from their CEO. And outcome was several employees clicked on the link, leading to the significant data breach. But a lot of people were aware about this cyber security phishing attack, and because of that they just didn't click on the link, and though a lot of data went out, but a lot of data was saved as well at the same time. So now let's have a look at how AI can actually stop an attack. So how AI works in that scenario? AI combats phishing attack by analyzing email content. What kind of, see, AI is a kind of thing that works on the availability of data. So the first thing AI do is data collection. So they get their data from email, they get their data from web, they get their data from documents, and a lot of different kind of sources. Well, these are the three main sources. Then what happens is sorry, pre-processing. Pre-processing have several steps. What are these several steps? It checks for signature rules analysis. For example, there is prior signature done by some higher authority of that company. It matches it. For example, sometimes if you have tried to cash your money using check, so on check you need to mark your signature. If your signature is not similar or same, exact same to the signature you used to do or you have submitted as a document in that bank, your check would get cancelled. So that is what it is, signature and rule analysis. Same way AI also does it here as well. That if there is some prior document or prior thing that was signed or ruled by someone else with the higher authority, if it is matching, if it is a full exact match, then it would take it further. If and then not, then we would have supervised ML analysis. What is supervised ML analysis is that, for example, what kind of data we have, it would take it, analyze it, and then if it is a legit data, then it would go for threat scoring and everything. Then we have visual AI analysis. It is also a very important part. It uses what kind of person has sent it, like this identity is even present in this current company or not, is it our client or not, and what it is it, right? Then we have unsupervised ML analysis. Then it convert, and then it goes to this decision making part where it decides that okay, even this has some threat or not, or we are safe or we are having some threat. So now let's look now how technically it works. So it uses NLP. What is NLP? AI analyzes the text of the emails to detect suspicious language and patterns. Then we have behavior analysis. What is behavior analysis? AI monitors user behavior for sign or phishing, such as clicking unusual link or accessing unfamiliar website. Example, an AI system might flag an email with urgent language and a suspicious link, alerting that the user and the security team before any damage is done. Now, how AI is trained? AI systems are trained on the large databases of phishing email and legitimate communications. Now it requires continuous learning. As a new phishing tactics emerge, AI models are updated to recognize how they should counter them and how they should understand how an incident report response and report should be created, right? For example, there is an healthcare organization implemented by an AI powered email security solution that reduced successful phishing attack by 85%. Now let's look into our second section of this session, that is automated incident response. So what is, let's first understand what is incident response, and then we would understand what was the problem, and then what were the measures that we took to complete this, and how to overcome this. So what is incident response? Incident response involves identifying, managing, mitigating security incidents. Now it has several kind of phases. What are these phases? These phases are, first we would prepare. What is preparation? Developing and maintaining an IR plan. What is IR plan? Incidents response plan. For example, we all face that if this kind of threat comes, what are we going to do? Same way we have incident response. If our company or if our data is attacked by someone, how we would respond to it. That is called maintaining an IR plan. Training staff and setting up detection system. Now detection and analysis. Identifying and analyzing potential security incidents. Now we have containment. What is containment? Is isolating affected systems to prevent further damage. Then we have eradication. What is eradication? Removing the cause of the incident such as malware, recovery, restoring systems to normal operations and ensuring no further compromise. Then we have post incident activities, that is reviewing the incidents to more future response and efforts. Now we have like, okay, but we understood like what is IR. Now why it is even important? So it helps us in minimizing impact. Effective IR reduces the impact of security incidents, protecting data and maintaining business continuity. Example, a retail company quickly contained a ransomware attack by isolating affected systems, preventing the spread of other parts of the network. Now, sorry. Now let's have a look at the problem with the manual IR. Like why did we see, we are talking about automated IR. Same way we talked about automated security or automated AI, right? But what were the actual challenges that we were facing? So we were facing some challenges with the manual IR as well, and that was uh, we can say labor intensive, leading delays, and detecting and responding to incidents was very time taking. What were the challenges? Volume of alerts. Security team can be overwhelmed by the sheer number of alerts, increasing the risk of missing critical threats. Now we have, secondly, we are humans. We are not machines. So human error is a very common kind of error. Human error manually processes are prone to error, which can result into inconsistent and ineffective responses. For example, in a large organization, a single security analyst might need to shift through thousands of alerts daily. Now this makes it very difficult to prioritize and respond effectively. Now, these were the problems with the manual IR. Now, how? Like, let's understand it with the help of case study. A financial institution experienced a data breach by using manual IR process, failed to identify and contain the threat in time. So outcome, the breach resulted in the significant financial loss and damage to the company's reputation. Now we have what, introducing to AI powered SOAR. What is SOAR in the first place? That is security orchestration, automation and response. It means that your security is orchestrated, means it is lined up, means it is automated. And if our company or some place or it with some data, we experience any kind of threat, SOAR is very automated security response kind of thing, where if you feel or if your data faces some kind of error, automated response is given and automated measures are taken to stop the attack. So security orchestration, automation and response platforms are used to automate AI and streamline IR process. Now integration. SOAR integrates with the various security tools such as SIEMs, firewalls, endpoint security solutions to collect and analyze data. Example, a SOAR platform can automatically correlate alerts from different sources, providing a comprehensive view of an incident. Now, what are AI capabilities actually in SOAR, right? So, automated analysis. AI algorithm analyze data to identify threats and determine the workflow automation. SOAR platforms execute predefined responses and actions such as isolating affected systems and notifying stakeholders. Basically, every time stakeholders are the one who needs the response report like first handed. Then we have case study. For example, there is a telecom company reduced its mean time response, that is MTTR. What is mean time to respond is when you get a threat and you perform any steps to stop that threat. That is called mean time to respond to incident by 70% after implementing AI powered SOAR solution. Now, how SOAR works? Wait a second. Now we would see how SOAR works. So SOAR platform ingests data from multiple sources such as SIEMs, SIEMS, firewalls, endpoint security, and it analyzes the algorithm and the data. It analyzes the data and identifies threats and determine the appropriate response actions. And then we have automated workflows. Predefined workflows execute response actions such as isolating affected system, blocking malicious IP addresses, and notifying stakeholders. Upon detecting a suspicious login attempt, a SOAR platform can be automatically lock and affected account and notify the security team. Now, what are benefits of automated AR? Benefits of automated AR is we have reduced response time. That is, automated IR processes respond to incident faster, minimizes the potential impact, and consistency. What is consistency over here? Automated workflows ensure consistent and effective responses, and resource efficiency. Like for example, by automating repetitive tasks and security teams can focus on example more complex can focus on more complex and strategic activities that is required by a company to perform their security posture. For example, there is an e-commerce company reduced its incident response time from hours to minutes after implementing an automated IR. Yeah, let's move. So basically, these are the few ways in which we consider it beneficial benefits of automated IR. That are, it is faster in detection and proactive issue prevention. Then we have efficient notification and alerting. Then we have orchestration and workflow automation. Then we have prompt contentment and redemption. And then we have detailed data analysis and so on. It is very detailed part about IR. Now we are moving on to the third section of our third section of our session, that is security posture management with AI. What is security posture in the first place? Security posture is a set of tools or is a set of policies that is used by a company or a retail store or anywhere in any company to make sure that their data is safe. Now, security posture can contain different kind of tools, it can contain different kind of policies, it can contain different kind of roles. Now, earlier than this we implemented automated or we implemented AI, there were manual security assessments because threat is not a kind of thing, these cyber attacks is not a kind of thing that has been implemented very recently. These are been implemented for years now. People have been cyber attackers or ethical hackers for years now. And there were system earlier that we used to do manual security assessments, and now we are moving towards AI and automated assessments. So what were the limitations in the manual security assessments that we needed to implement AI, or we needed to implement any sort of automation? So manual security assessments are very time consuming and may not be comprehensive. Challenges are resource intensive. They require significant amount of time and expertise, which can be very costly. Inconsistency. Different assessors may produce varying results, leading to potential gaps in security. For example, someone has expertise of 5 years, someone has expertise of 7 years, and they both can have different views about a particular attack, and they can have different kind of incident reports. Yes, they can have different kind of incident response as well. So this shows what? This shows the inconsistency of different people telling us different things. Now, for example, a manual assessment might overlook a certain vulnerabilities due to human oversight. For example, we have a tech company which has suffered a data breach because a manual security assessment failed to identify a critical vulnerability. Outcome of this is the breach resulted into a significant financial and reputation damage. Just look at it, how bad it would be if you have people's data and you just lost it in front of like 1,000, 10,000 and lakhs of people. That is high amount of data and very critical data, right? So now we could understand why, now we understood that why we are, what is the limitations of this manual testing or manual security assessment, why we consider this AI powered SPM. What is SPM? AI powered SPM is security posture management. What are benefits of this security posture management? AI powered SPM provides continuous monitoring and assessment of an organization's security posture. Now, it is not a kind of thing, for example, even if you are sleeping at night and you have a IT firm and you have a security posture management and you are into Google Cloud and you have purchased or you have like plans for your security posture management, right? Even if you would be sleeping, it monitors your data 24/7. It monitors your what all changes are being made in the database, who is making it, everything is well performed and everything is well observed. Now, what are capabilities of this AI powered SPM? It is continuous monitoring. AI system continuously monitors for vulnerabilities and compliance issues, and proactive risk management. AI identifies the addresses and risks before they can be exploited. For example, an AI powered SPM solution detected and resolved a misconfigured firewall rule preventing potential unauthorized access. How good it is. Now let's have a look at this diagram as well. So this is the workbench. This is provided by Google itself, that how their security posture management works. So you have playbooks, you have threads, you have total malware, you have OSS virtualization, you have GitHub repos, you have different kind of frameworks that can be put in together, and it could be plugged in by using a plugin, of course. And then your security threat management scans everything, and then only it performs the things further. Now let's have a look at the success story that was completed by Google Cloud AI Security, and how they helped them achieve this thing and how was this possible. So this success story is of a healthcare firm and a healthcare firm and a financial firm as well. So for the, let's look at the, according to this diagram, let's look at the financial services firm. So, how AI significantly improved the security posture of a financial services firm? In the background, the firm was struggling with numerous security incidents due to limitations of traditional security measures and manual incident response process. Now, challenges were there were high volume of security alerts. There were leading to alert fatigue. That means even though there were like high amount of security they have implemented, but they were on manual basis, they were not taking it on cloud, or they don't have any sort of automation in it. Even though there were threats, and multiple threats, they were not able to figure out, and they were not getting alerts in time. How bad it is that you have a threat and you are not getting an alert for it. Then it was slow incident response. What is slow incident response? Now, if you are not getting the threat alert in the time, then how you would be able to perform things or perform methods to stop this I forgot the name. How would you stop this attack, right? If you will not have the alert in the first place. And it was difficulty in identifying that for what kind of alert, for what kind of attack we need to perform what kind of measures, or how we can implement it in our security, that we should not face the same thing afterwards as well. So the firm dedicated to implement AI powered security orchestration and automation response. Now, SPM solutions, how were the steps taken? Let's understand what all the steps they took to perform this SPM, right? So data integration. The AI solution were integrated with the existing security tool, including SIEMS, and firewalls and endpoint protection systems. Now we have automated threat detection, that is, AI algorithms were deployed to continuously monitor and analyze network traffic, user behavior, and system logs. Incident response automation, automated workflows were created to handle common incident response tasks, such as it was isolating compromised systems and notifying relevant stakeholders. Now, how good it is that earlier we were not getting alerts, earlier we were not able to resolve in time, earlier we were having like massive data breaches. Now, how it has helped us in data integration, automated threat detection. Now we can automatically analyze our network traffics, and we can automatically get our incident response automation. Now, how did it result into? It result into improved detection and response. The AI powered SOAR platform introduced the mean time detect that we talked about, MTTR. What is MTTD? Is the mean time when you take to detect that you have faced, your company has faced an attack. That is MTTD. The mean time to respond. That is, the company took time after detecting the threat, and the time took to respond to it. So, to security incident by 60%. Earlier we were facing like what, 100% of data breach was there. Now, by implementing AI, by using Google Cloud AI security, we took it like what, 60% reduced. How good it is. Then it has enhanced efficiency. What is enhanced efficiency? By automatic routine tasks, and security team could focus on more complex and strategic issues, improved overall efficiency. Now, what were the reduced false positives? Those were AI's advanced analytics significantly lowered the number of false positives, reducing the alert fatigue and allowing the team to prioritize genuine threats. System detected the threats early and isolated and affected the account and notified the security team, and prevented the data breach and prevented financial loss as well. So, from this case study, we understand that how AI powered solutions can transform a company's security posture, making it more resilient to involving cyber threats to financial services. Firm now operates with a greater confidence, and now they have like opened many more branches, and same way they are implementing same way they are implementing Google AI security. And according to one of the research, in above I think 500 Fortune companies, you can say what are 500 Fortune companies are the companies which generate the maximum amount of profit every year. They are choosing cloud AI security, and that is Google Cloud AI security systems in their security postures. So here it is. So thank you so much everyone for joining me today here. I'm cloud intern at Bhumitat, and if you have any doubts or anything or any questions, we can take it to my LinkedIn as well, and I have a TopMate account as well, and that is completely free for students. You guys can come and ask me any doubt anytime, and I'm available to solve it. Thank you so much for having me here today.
Thank you so much for your time. Presentation was very good.
Thank you.
There's just a few questions that I saw in the chat. Let me just pose them to you. The first one was when you're referring to is it Mahesh is asking, is it only for Google Cloud or AWS and Azure can also access it?
Okay, so actually, can you please drop the questions in the comment box because I'm not able to view you properly? Is it only for Google Cloud, AWS, and Azure can also access it? Okay, every other, we have three major cloud providers that are Google Cloud, AWS, and Azure. Three of them have different security postures and have security measures divided in very different ways. For today we are talking about Google Cloud, and as I discussed, for the 500 fortune companies that generate like maximum profit, they are choosing Google Cloud security posture, right? So I think here my answer is justified.
Yes, it is. The next question was, how can we ensure that AI-powered security solutions in Google Cloud
How
are
can
not
we
biased towards certain types of attacks?
No. How can we ensure that AI powered security solution in Google Cloud are not biased towards certain type of attacks or user behaviors? No. Because if you go to Google Cloud's website, where they showcase you the kind of solutions they provide. If you go and read over there, they have particular blogs, and it contains more than different, you can say more than 20 30 types of attacks. And no, it is not biased with any one kind of what do we call that, attack or user behavior. No, it is not biased. Basically how Google Cloud works is, if they find any some new kind of attack, they very soon, like immediately, on immediate basis, they train their AI models to adapt and learn, and to learn how they can stop that kind of like error if they face it again. No, it is not, because it can't be biased as well, because threats are very new nowadays, so you can't be biased to certain kind of threats.
Okay, and I guess the last question we had was,
Mhm.
can you elaborate on specific Google Cloud AI services that are used for threat detection and prevention?
Okay, particular services they are using? No. Why?
Yes.
Because there are AI services. There is a whole posture in there that you can pick and choose according to your IT firm, according to your requirement. So it you have Cloud Armor as well. We have different kind of roles. We have different kind of policies that can be used and updated according to your needs. So there is not any dedicated thing, but you can ask for it. Basically how good it is, you can just go there on their website. They have their support system. Literally you can write down there that I want to do this, and they would guide you step by step that what kind of services would be best for your kind of like thing. For example, if you have an e-commerce website, how you can implement security posture there. If you have a healthcare medical shop or healthcare firm, how you can implement SPM there. So it works like that. Thank you.
Thanks for that. I believe that was the last question that we had for now.
Okay. So I think we are done with today's session, and thank you so much for this opportunity.
Welcome. Let me prepare for the next session in a few. But you can just give them your social media handles again, so it's easier for people to reach out to you if they have any further
I'm
questions.
leaving my LinkedIn in here. Just give me a minute. I have dropped my LinkedIn in here. So,
Thanks. I've shared it on the chat.
okay, thank you so much.
Thank you for your time once again and have a good evening. Just a minute. Let's. Hello, Michael.
Hello, hi.
How are you doing? I hope you're ready.
Yes, just give me a second. I am set and all good. So, will you be displaying from your end or my end?
No, your end.
Okay, perfect. That means I will be sharing my screen if I am correct.
Yes.
That works. Just give me a second. Let me close the window. And yeah, hi.
Next up, I'm excited to introduce our next speaker, Michael Mekulei, a seasoned senior software engineer with a keen focus on, I don't know how to pronounce that word, Kubernetes, or is it Kubernetes? I don't know how to pronounce it, and DevOps. Michael is also a Google Cloud developer expert on cloud, and as well, yeah, I'll let you take the stage. You're muted.
Thank you. Am I live now?
Yes, you are.
Hello, everyone. Hi. How is everybody doing in Kenya? Hope everybody is doing great. Hope everyone is doing fine. We are going to be looking at infra level observability in Google Cloud Monitoring, and yeah, so I will just present slides. This is perfect. Google Cloud. Let me see. From studio. I am just trying to present. Yes. Can you see my screen?
Yes, you can.
Yeah, so this is me. Sorry, this picture was taken a long time ago, 2 years ago. I probably need to update this picture, but it works for everything. And yeah, so today we'll be talking about infrastructure level observability in Google Cloud Monitoring. Um, yeah. So I'm a senior DevOps engineer. I am a Google Dev expert for Google Cloud. I am a fintech enthusiast. I do financial security. You can find me on Twitter there. I live in both Nigeria and the UK. And yep, I'm sometimes I'm in Africa, sometimes in Europe, and yep, that's how it is. So the first thing is understanding observability. The key thing here is we are going to try to be dissecting observability. What is observability? How do we observe metrics? How do we look through items? How do we resolve issues that come up? And we are just going to be working in that spectrum of what is observability, how we set up observability in GCP, and then how we just do it. First of all, you have to understand observability. In the context of cloud computing, it refers to the ability to monitor, understand, and predict the state of a cloud environment. And it is key for ensuring reliability, performance, and security. So what are we monitoring? We are monitoring metrics, we're monitoring logs, we're monitoring traces, we're monitoring alerts and notification, we're monitoring visualization and dashboarding. Why observability? Why do we need to observe metrics, logs, and all those things? We are looking for, first of all, enhanced problem solving, performance optimization, proactive issue identification, and then enhanced troubleshooting. Then also, we are looking at automation and integration. So we want to solve problems faster. We want to, if metrics are going bad, we want to solve them faster. We want to optimize our performance. We want to continue proactively troubleshooting. And then we are focused on automating quickly and integrating. So infra level observability is essential for ensuring that the underlying infrastructure is performing optimally. You do not have large infrastructure for little resources, and then there are no issues that could lead to a service degradation or outage. So introduction to cloud monitoring. Oh, okay. I think yes. So introduction to cloud monitoring. Cloud monitoring is the tool in GCP that enables us to observe all these things. So cloud monitoring involves continuously tracking, analyzing the performance, continuously tracking and analyzing the performance and availability of cloud-based application and infrastructure, and then using metrics and alerts to provide visibility into operations, health, and performance. So cloud monitoring enables us to do all this stuff, and then it enables us to just connect, to build, to monitor, and to visualize. And cloud monitoring is actually a big sector in GCP. So in GCP cloud operations, we have GKE, we have GKE on-prem, and we have Cloud Run. So let's say these are containerized deployments. And if we are feeding into cloud operations, we are looking at feeding into monitoring, we're looking at feeding into logging, we're looking at feeding into error reporting. We are also looking at feeding into application performance management using CloudTrace, Cloud Profiler, and also Cloud Debugger. So these 6 tools are what we use to manage the cloud environment: monitoring, logging, error reporting, trace, profiler, and debugger. So powering observability. With cloud monitoring, we have a group of 5 tools that we use, a very light suite of observability tools. At a point in time, I've used everything: cloud monitoring with alerting, cloud logging for logs, cloud trace for latency, cloud debugger for debugging code, cloud profiler for CPU and performance. So these tools, they all do different things, they all do different stuff. They all have libraries either in Terraform, in Pulumi, or in CDKTF. And this suite of tools are designed to provide comprehensive monitoring, logging, and tracing capabilities for application and infrastructure hosted on its platform. These tools also form an integral part of Google Cloud Operations Suite. So these 5 tools are the key tools that we use in GCP. You can see them: cloud monitoring, cloud logging, cloud error reporting, cloud trace. There are 6 actually: cloud trace, cloud debugger, and cloud profiler. So cloud monitoring. This tool allows users to perform performance, uptime, and overall health of cloud applications and infrastructure. It provides the ability to track system metrics, set up dashboard, create alerts and reports, and you can also monitor Google Cloud services as well as third-party applications. Cloud monitoring is particularly useful for tracking resource utilization, system latency, and error rates. There is no service on GCP that cloud monitoring cannot track. So cloud monitoring can track, cloud monitoring can create alerts, it can create metrics, it can set up dashboards. And yeah, that's what it is used for. So across the Google suite of services, across compute storage, big data, machine learning, cloud monitoring is across all of them. You have cloud monitoring, can monitor App Engine, can monitor Compute Engine, can monitor Container Engine. Cloud monitoring can even monitor Cloud PubSub when you are using your subscriber and your consumer to push messages or pull messages. Cloud monitoring can create alerts, can create metrics based on that. You can also use cloud monitoring in data flow, in data proc, in data lab, in division API, any API that is used in GCP can be configured into cloud monitoring. Cloud logging, this is probably the cost house of GCP because a lot of people have spent a lot of time optimizing cost. Optimizing cloud cost in GCP. This service offers powerful log management, managing logs, analyzing logs, aggregating logs into cloud buckets, and then comprehensive log data to help troubleshooting, monitoring application performance, and ensuring security and compliance. So cloud logging allows users to search, analyze, and log on log data. That's it. Google Cloud Trace. So this is a distributed tracing system that helps to in collecting latency data from applications. Google Cloud Trace focuses on latency. So it is distributed in nature. It focuses on collecting latency data. It allows you just track how requests propagate through application and identify where delays are occurring. And it is valuable in microservices architectures to understand the performance of various services and interactions. So, yep, there's also error reporting. It's used to count, analyze, and aggregate crashing in your system. It can take from logs, it can take from monitoring. It notifies users of real-time errors and provide insight into the frequency and impact of each error. And it also helps you to diagnose. It helps you to diagnose and also helps you to resolve errors pretty quickly. So Google Cloud Error Reporting, I've also used this in Terraform. You can use it to diagnose errors. You can use it to solve errors. You can use it to configure alerts. So the ideal thing also is that every piece of this monitoring puzzle works together. So whether you have the errors coming from the debugger or error reporting or even log-based errors, you can feed everything into cloud monitoring and it allows you those errors either on Slack, either via email, or either via phone call. And it helps you quickly resolve those errors and it helps you keep your uptime and your availability. There's also Cloud Debugger. Cloud Debugger allows developers to inspect the state of a running application in real time without stopping or slowing it down. With Cloud Debugger, you can set up breakpoints, you can check and inspect the state, you can set up values, you can set up state with Cloud Debugger, and you can even inspect variables in runtime without slowing down your application, without stopping it. It is very light. It has available libraries in Python, in Node.js, in Go, and you can use it in your code. And it is useful for debugging complex production issues that might be difficult to replicate. Then we have Cloud Profiler. Cloud Profiler continues to analyze the performance of CPU and memory-intensive applications in production. So migrating your observability stack to GCP, first thing you need to do is evaluate what you currently use for observability and then identify the specific needs and goals for the migration. Then also determine the scope of the migration, application services, and what data needs to be migrated. So assess, plan, and migrate. So you can evaluate current availability tools, identify the specific needs, and then determine the scope. You can prepare your environment by getting started with GCP observability tools, preparing on observability, or monitoring, on logging, understand the features and capabilities and how they can meet your observability requirements. So you can also set up a GCP stack and access the necessary services, then configure network settings and permissions for secure and efficient data transfer. Then you can also do data migration and integration. So migrating existing logs, metrics, and trace data. This time around, you're migrating all your data, you're migrating all your logs, you're pushing logs to a bucket, you're setting up log buckets, you're setting up new alerts, you're setting up fresh alerts, and then you are embedding GCP observability tools directly into your code and into whatever application or infrastructure that you have. That's all. Short one there. So I can now take quick questions and we can provide answers to those questions. Yeah.
Thank you for that. I think the first question that I saw was in regards to What are the most common challenges that organizations face when they're implementing infra-level observability, and how does Google Cloud Monitoring address them?
So, infra level observability, the big challenge is having the right metrics. Having your starter metrics. What metrics do you want to start with? What metrics do you want to start monitoring? What metrics do you want to focus on? Those are very, very big questions. A lot of organizations set up metrics that are not valuable. They set up errors that are not refined. You might have alerts that are not picking the right stuff. You might have alerts that are not firing when things go bad. So the big thing is having the right alerts, having the right log-based alerts, having the right infra level alerts, having the right application layer level alerts, and just making sure that whatever needs to be used, worked upon, whatever needs to be extended can be. GCP will give you a base version. So whether you're looking for window-based alerts or you're looking for instant time alerts, GCP enables you to do that very quickly, very easily. There's also a Terraform library that enables you to integrate alerts very quickly and enables you to be able to recreate alerts across different stack, whether in Cloud Run, in GKE, or in GCE. So yeah, the key thing is defining and refining your alerts and then making them usable.
Just to follow up on what you said, then how do you how do you define the infra-level observability and differentiate it from application level observability?
Now, infra level observability is at the infrastructure layer. So there's network level observability, there's infra level observability, and there's application level observability. Network level observability is whether you're monitoring your network. What kind of IPs are coming into your network? What kind of IPs are hitting the network? What's the frequency of the network? Firewall, what firewalls do we have in place? How are the firewalls performing? What are the firewall logs? Network level, that's network level observability. Infra level observability, give me a second. I need to turn off my alarm. Just give me a second. Yeah, sorry about that. I had to turn off my alarm. So, infra level observability is what is your infrastructure. So, what infrastructure do you have now, whether Compute Engine, whether Kubernetes Engine, whether Cloud Run? What infrastructure do you have now, and how are we scaling that infrastructure? And how are we utilizing that infrastructure? That's infra level observability. Application level observability is what logs are your application generating? What errors are your application generating? How is your application performing? How many times does your application crash? So what are the necessary debug points that are in your application? So we layer observability across the three stacks, whether infrastructure level, whether network level, or whether application level. So yeah, that's pretty much the difference.
Okay, thanks for that. I think I also wanted to ask, so how do you integrate, like how does cloud monitoring integrate with Google Cloud Services for comprehensive observability?
Yes, it's pretty interesting. You can use the console. Okay, so the console is pretty descriptive. You do not have to start with code. First of all, you need to set up an SLO, a service level objective. Then you set up your SLO and attach a metric with it. It is not, you don't have to start with code. If all your infrastructure is in GCP, you can already have access to cloud monitoring. So you just go to cloud monitoring, set up an alert, say, okay, whenever my memory gets to 90% on this resource, alert me on Slack. So you do a Slack integration, or whenever the memory of this server gets to 95%, alert me via email. You can set up your notifications, you can set up everything via console. So you do not have to code. The reason I advise coding is so that you can make it reproducible and you can make it You can make it reproducible, and you can reuse, but you do not necessarily have to write code. You can do everything via console, and GCM has access to the entire infrastructure layer. So you do not have to configure anything special. It's easy to set up and easy to use.
By any chance, are you able to give us like a slight demonstration on how to do that?
Do you want to see something?
Yeah.
I might not be able to give you a demonstration right now because I will have to log into the company account. But yeah, maybe another time.
Okay. Also, there's another question by Davis about is a hybrid cloud management platform advisable for use?
That's a good question. You can use a hybrid cloud management platform, but you need to ensure that you have the necessary skills to manage your hybrid cloud. So if you have a hybrid cloud management platform, that means you have some on-prem resources and then you have some on the server resources. What tool are you using to aggregate logs, aggregate alerts, aggregate dashboard to the same place? Are you keeping them on GCP or are you keeping them outside of GCP? Because of GCP's integration, I would advise you keep them on GCP. If you are keeping them on GCP, how often do you need to refine your logs? How often do you need to refine your alerts? How often do you need to refine your metrics? These are extremely quick key questions that need to be answered. And I will always advise that you do this very frequently. But the key thing is having the right knowledge to be able to do these refinements to set up hybrid alerts, hybrid logs, and making sure that everything is safe. So, yeah, that's pretty much it. Hello, Eugene.
Hey, Michael, thanks for that. I think
Mm-hmm.
you've answered all the questions that we had,
Mm-hmm.
unless someone else has another question. And you still owe me a demonstration, as you said.
Eh?
Later on. It doesn't have to be today. I was just referring to the demonstration that you had mentioned, maybe
I,
later
I
on.
promise to give you a demonstration. Yes.
No worries. But
Yeah.
meanwhile, I guess you can just tell others how they can reach out to you.
Yeah, you can reach out to me on Twitter, Monaring, on Twitter, mostly on Twitter. That is it. MONN. Okay, let me. You can reach out to me on Twitter. We can talk on Twitter, MONNARENE, and that's pretty much it. So, yeah.
Thank you for that, Michael. It's been a really insightful session for most of us. Okay, for me and everyone else that
Yeah.
was watching. I've learned a lot.
Yeah. No problem. That's nice.
Wait, there's something I need. Oh yeah, there's this question about what are the best practices that you'd recommend for designing an effective observability strategy using Google Cloud Monitoring?
Okay, first of all, you want to have error reporting. So you want to have errors, you want to have alerts, you want to have dashboard, you want to have logs. You want your logs to be connected to everything, and you want everything to feed back to the alerts. So alerts, dashboard, errors, logs. Logs should be able to feed into your alerts. Errors should be able to feed into your alerts. You could also create dashboard level alerts. So the first thing I would say is start with a baseline. First of all, determine what level of observability you want. What is your service level objective from your service level indicator? So you determine your service level objective. Let's say we want 99% availability over a month. Then you determine what your error budget is. So you determine your SLO. You come to GCP, you set the SLO, you connect the infrastructure, and then you make sure that everything is connected and the alerts are working. You can also test alerts. It does not have to be when the SLO is reached. So, like I said, alerts, logs, metrics, and then I mean alert logs, dashboards, and errors. You make sure everything is connected to alerts, and you make sure logs read everything. So yeah, that's it.
Oh, that's all for me. Yeah, that's generally all the questions we had.
Yeah.
Okay. Yes, for me, what's left is just to wish you a good evening. Cheers.
Cheers.
And also thank you once again for sharing your sharing your knowledge with us.
No problem.
Let me just send
Yeah,
your
one more
X.
question from me. What's the size of the viewership?
I'm not sure. It keeps on fluctuating.
What's the average size? Because I need to record that.
Around 20.
Oh, okay, that's cool. Yeah, that's awesome. Nice.
Oh, there's a question as well. Can you state examples of hybrid platforms? That's a follow-up question from Davis.
So does it mean hybrid cloud platforms? Because there are no hybrid cloud platforms. There are cloud agnostic tools or cloud native tools, but no specific. There's GKE on-prem that can use both on-prem and on GCP, but there are cloud agnostic tools or cloud native tools. Yeah, so that's it.
Hello. Thank you for that.
Yeah,
I think he's answered, unless I have to wait for a response from him, but I think he's answered.
yeah.
And have a good evening and thank you for your time.
Bye bye.
Bye. We'll be back in a few. Cheers. Hey guys, so that's it for now. We'll be back in a few. Enjoy the break. We'll keep informed on Twitter. Thanks. Have a good evening.